at the school. Hopefully everything will be open tomorrow, and I will be there tomorrow. Okay. And I think Estrella, you were going to ask for the unit circle when you come. Sorry, I'll get it to you tomorrow if you're going to. Well, I don't know when you're going to be. I think you're asking. Were you asking for me, Estrella? No, you were there. Was it Estrella? Someone was asking me.
Yeah, I was.
It was you. Okay. Sorry about that. Okay. Let's go with the basics. Let's graph first. I'm going to go with basics. I'm just going to graph sine and cosine. Okay. But guess what? You know how you have H and K and then A that shifts and stretches the parabolas and the functions and all that stuff? Well, that's what we're going to be doing with sine and cosine. It's not H and K. We have different letters, but we're going to be able to shift them, stretch them, flip them, all that stuff. But first, let's get the basics. Okay, so here we go. Let's first graph the function. Everybody graph this with me. Y equals
You're not presenting.
Sine. Oh, man. Good point. Let's present this sucker. Thank you for saying that, because then I would have to do it all over again. We'd be here forever. Okay, again. All right. So we're going to graph y equals sine of x. Now, remember, sine is the x and cosine is the y. Even though I'm plugging in sine of x, but we look at our unit circle. Remember we said here, when I say x and y, remember we said sine of 30 is 1/2, cosine of 30 is root 3 over 2. Okay? Sine of 45 is root 2 over 2. Sine of 45 is this root 2 over 2. Cosine of 45 is this root 2 over 2. Sine of 60 is root 3 over 2. Cosine of 60 is 1/2. Remember that? Now, all these numbers here, I don't want to graph these. These are ugly. 1/2 root 3. What the heck? The numbers that we're going to graph are these. 0, the 90, the 180, the 270 down here, and the 360. However, I am not going to show you how to graph these in degrees. We're going to graph them in radians. So we're going to graph, all of these are points on the graph, but the main points we're going to look at are going to be pi over 2, pi, 3 pi over 2, and then 2 pi and 0. Okay? So we're going to graph everything in radians. So let's go ahead and graph y equals sine of x. So here we go. Okay, now let's label our graph. This is my x-axis. This is my y-axis. We're going to use this graph to graph y equals sine of x.
Are you still presenting?
Am I not presenting?
I don't know. I don't
I am
think you
not.
are.
I'm not presenting. What the heck? What's going on with me today? Okay. Am I presenting now? Am I presenting?
Yeah.
Yes.
No? Okay,
Yes.
thanks. Okay, let me say this again. Remember, thank you. Okay, remember, x is my cosine, y is my sine, right? If I solve it, if I say, what is cosine of 30? You'd say root 3 over 2. What is sine of 30? 1/2. What is cosine of 45? Root 2 over 2. What is sine of 45? Root 2 over 2, right? Get it? What is cosine of 150? My x is negative root 3 over 2. Now, when we graph these, we are not going to graph in degrees, though. We're going to graph in radians. Okay? So I'm going to say, hey, what's cosine of pi over 3? You'll say 1/2. But these numbers here, 1/2 root 3 over 2, root 2 over 2, root 2 over these are ugly. I don't want to graph these. These are just me. You guys can graph them if you want. I don't know what that negative root 3 over 2 equals. I don't know what that number equals. But the easy numbers I'm going to graph are this. 0, 1, negative 1, 0, 0, negative 1, 1, 0. So the points on the table that I'm going to graph are going to be these radians, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So that's what I'm going to graph. So here we go. I have my y equals sine x. This is my function I'm going to graph it with. I'm going to graph it in a coordinate plane like that. I'll let you guys set that up. Actually, you know what? I forgot my pen. Okay, I'm back. Sorry, I forgot my pens. So here we go. So I got my pens, my different color pens. I'm drawing in different colors. So here, let's label our function. Okay, you can do whatever you want. I'm gonna skip every other one for now. Let's go hit 2, and we're gonna call this basically. I'm gonna do pi over 2 as my label. Then we'll skip 2, and then this one is gonna be. Hit this one, pi radians. Look at your unit circle. That's the 180. And then skip 2. What's the next one going to be, do you think? You know what? Tell me. Look at your unit circle. I graph pi over 2. I graph pi. I graph 3 pi over 2. Right? I got my 0. I got my pi over 2 up here. Can you see that? Pi over 2. I got my pi. Guess what I'm going to do next? 3 pi over 2. I'm increasing my pi over 2 every time. So I got here 3 pi over 2. And then finally, my last one will be 2 pi. We'll stop at that for now. We'll have different ones. Let's go in the negative direction. If this is pi over 2, then guess what? This is negative pi over 2. Skip 2. I got negative pi. Skip 2. I got negative 3 pi over 2. And then I got negative 2 pi. My y-axis, I'm just going to increase by 1. Negative 1. Okay, there you go. Boom. Now let's graph y equals sine of x. This is what you should have all this set up right now. Have it all set up. Alexis, how are we doing? Are we ready? Are we good?
Yeah, I'm
You all
good.
caught? All right, Alexis is caught up. Let's see. Camila, how are you doing? Are you good? Are we caught up? Can I move on?
Yeah.
Okay. So remember, sine is equal to x. So let's go ahead and look at. We're gonna look at. So we want to know what is. Okay, this is 0. What is the sine of 0? The sine of 0 is 0, right? That's my y. Sine is y. So I got here sine of 0 is 0. And then let's look at pi over 2. What is sine of pi over 2? It's equal to 1. Actually, you know what? Let's see. I want to show you the pattern first. Let's graph all the zeros. Look at my pi. Sine of pi is 0, 2. Sine of pi is 0. Sine of 2, my other sine of 2 pi is also 0. So sine of 2 pi, what is my sine? It's my y there, it's 0. So my zeros of sine are 0, pi, and 2 pi. Those are my 3 points that I want, okay? Look at those points. There are 5 key points for graphing sine. We graphed 3 of them. Now, what is sine pi over 2? Sine pi over 2 is 1. So I have here, sine pi over 2 is 1. What is sine 3 pi over 2? I look at my 3 pi over 2. I look at my sine as my y is negative 1. So it's negative 1. And I go down here to negative 1. And then those are your 5 key points. 1, 2, 3, 4, 5. I got my 3 zeros, one above, one below, and you just connect. And it's going to continue. And that's y equals sine of x. Now to graph the negatives, basically, I'm going to go in this direction. This would be negative pi, so my sine would be negative 1. And then this would be this is negative pi over 2. This would be negative pi in this direction. But what you can look is negative pi over 2. Look at my zeros. My zeros are again going to be this one and this one, negative pi and negative 2 pi. Those are going to be my zeros. And if you look on the unit circle, I go in the opposite direction, negative pi, I got a 0, and then I go back here, 2 pi, I got a 0. Okay, so those are my zeros. And now I'm going to go 1 below, 1 above, and then that's going to be your whole sine 2 periods. Boom. There's your sine function. Notice, sine starts at 0 and it ends at 0. When I say ends, it does go on forever, but it continues the full unit of the circle, which we call 1 period. It ends 1 period in 0, and then it starts the pattern all over again. Starts at 0, ends at 0. There's 1 period. Starts at 0, ends at 0. There's another period. And that's how you graph y equals sine of x. Let's graph y equals cosine of x. And compare the two. One of the main things is you get the zeros of sine of 0, pi, and 2 pi. Hit those zeros, and then you put one above and one below. Boom, there's your sine. The zeros are at 0, pi, and 2 pi, and then you hit a point above, hit a point below, and you just connect it. Boom. So again, let's do this. We got 2 points. We're going to do pi over 2. 2 points, we got pi. 2 points, we got 3 pi over 2. 2 points, I got 2 pi. 2 points, I got negative pi over 2. 2 lines. I got negative pi, dot, dot, skip 2. Negative 3 pi over 2, skip. And I get negative 2 pi. And I'm going to go up to 1 also. 1 and negative 1. So then let's graph the sine. Now there's going to be 5. So remember, the 5 key points for sine are 0, 0 for pi, 0 for 2 pi, 1 above, 1 below. Blah, 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 blah. Now, what are my 5 key points on this side for cosine? So let's look at cosine. Remember, cosine is x. Let's do this in purple. Cosine 1. Let's do our zeros first. My x is 0 here at pi over 2. And I got a 0 here. My x is 0 at 3 pi over 2. So my two zeros are at pi over 2 and 3 pi over 2. Those are my zeros. Boom. Here, look at my zeros on sine. 0 is pi, 0, pi, and 2 pi. My zeros on cosine are pi over 2 and 3 pi over 2. And then let's look at cosine of 0 is equal to 1. So I go above. And then cosine of pi is -1. That's my -1. So then I go at pi. I go below, like I go above, below. And then 2 pi is also 1. I go back above again. And this is what cosine. Now, hey, very important. Look here. This is a curve. It is not a point. Make sure you curve it or else I will mark it wrong. It is more like a U here, not a V. Don't make it a V. Don't make it a point. Make it curvy. Okay, look at my zeros. My zeros are negative pi over 2, negative 3 pi. And look, I go above, so I'm going to go below. Then I'm going to go back above again. Boom. And then there you go. And there's my equals cosine of x. Oops, I didn't go below. Look at this. See, and sometimes see it's all messed up. Look at that. I didn't go down to -1. Wait, my -1's in a weird spot. My -1 should have been here. Oh, well. That's terrible. That's a little off. I got to redo that one. But okay, that's how you graph y equals sine of x, y is cosine of x. Are there any questions? That's the basics. That's my parent function. Those are my parent functions. Now we're gonna shift these, we're gonna stretch them, we're gonna compress them, we're gonna pull them, we're gonna push them, bring it up, bring it down, left, right. Okay, but those are our basic parent functions. We have to understand those. Are there any questions? I'm gonna get rid of this in 10 seconds. 5, 4, 3, 2, 1. Okay, let's talk about vocabulary. Am I presenting?
Yep.
Okay, cool. Here we go. Let's talk about some vocabulary terms. Oh, let's get this back to 100%. 100%. Okay. Okay, look at this right here. Can we fit all that in? Okay. Now, the characteristics of y equals sine x and cosine x. First, let's talk about the amplitude. The amplitude of the graph is 1/2 the distance between the maximum and minimum value. Basically, the amplitude is this right here. So from here to here, this is the amplitude. If you look at my function right here, the amplitude is from here to here. That is the amplitude. And my amplitude equals 1 because from here to here is 1. It's how tall the graph is. Now we can stretch the amplitude and make it taller or compress it and make it shorter. But when we talk about that, that is the amplitude. Now, let's talk about the period. The period is when we complete the function. Notice I start on top with cosine. I go down, and I go up, and I go back to the top. That is one period. A period is going around the unit circle one full time. So my period, if I look at my sine function, I start here, I go up, get back to 0, but I got to go back down again, and I go back down and I get to 0. And so my period is from, what color should I do? Do I have red? Red would be good, but I don't. Period is from here to here. That is my period. My period for this, it takes me one period is equal to 2 pi. That is my period. My period is 2 pi. And same with my cosine function. Look, my amplitude is 1 from the top to the middle. My period, up, down, up, and then back to the top is also 2 pi because it takes me 2 pi to go around the unit circle. Now, these are called periodic functions because they repeat. These are called periodic functions. It's a periodic function. Notice it's the same pattern over and over again, and it'll continue. It's just a wave that goes up and down. Makes it a periodic function. It is a periodic function. So both sine and cosine, these are all periodic functions. Okay, and we'll worry about the cycle. Cycle is half a period, but I'm not going to ask you about the cycle. Now, let us write this down. Write this down with me, shall we? Hang on. I'm getting to my... Let's put on our parameters of our sine function. Y equals a sine hang on a second here. Sometimes this is parentheses, sometimes it is not. But we're going to put b of x plus... Hang on a second. I'm looking at two different notes here. I want to make sure I'm consistent on how I teach it to you guys. Okay, so here I'm writing it down. Sorry, sine Okay, presenting. I am presenting now. Okay, so here are our parameters. For sine, it'll be y equals a sine b times x minus h plus k, and y equals a cosine b. For cosine, it's this. Now, let's look. What do these letters mean? Well, the absolute value of a is going to be our amplitude. The absolute value of a, so that's going to tell us, remember, how tall or how short it's going to be. Now, b is going to be my period. And the way we determine the period is we do this calculation. We do 2 pi over b. Remember, the period, remember the period is how long it takes to complete the cycle. So boom, one period for this is 2 pi. Sometimes it'll finish at pi. Got to finish the whole thing at pi. And then h is my horizontal shift. Okay. H is my horizontal shift. So remember, it's a negative h, so plus means left, negative means right. You shift the opposite of what it says. If it's a positive, you shift in the negative direction. If it's a negative, you shift in the positive direction, just like we did before on our other functions. And then we're going to have here, k is my vertical shift. And then we shift the midline. The midline is the middle part. Okay, so like here, I'll let you write all that down. I feel like I'm just lecturing at you guys. Hopefully, I mean, I just have no questions asked. Just hopefully you're understanding this so far. Make sure I'm doing okay. Let's see. Christian, am I doing okay? Are you awake or am I putting you to sleep?
Bro, you're doing good. I'm awake.
Okay. Okay, I just want to make sure. I mean, I know this is boring stuff. I'd be putting myself to sleep. Danielle, how am I doing? I'm sorry I'm not asking any questions. Are you doing okay over there, Danielle?
Yeah, you're doing good.
Okay. Are you doing okay is what I'm asking.
Yeah.
All right. So remember, my vertical shift is my k, it's my midline. So right here, my midline for this whole function will be right here in the middle. My midline is right here at x equals 0. Right here's my midline. That's my midline, and that's what you shift. Okay. All right, so let's do some problems. All right, here we go. I think we have enough information to solve all these problems. Let's see what we got here. Let's go with, and some of these I won't even do. I'll let you guys solve these on your own because I spent a lot of time. So remember, it's a periodic function. By the way, this is wrong. Look at this. This is not what this is asking, but it does not go up to a point. It has to go round. But we're going 441, 5 through 47, every other odd. In exercise 5 through 8, determine whether the graph represents a periodic function. If so, identify the period. Okay, so this is a periodic function because it repeats. It's not a sine or cosine. But what's the period? Well, it looks like it's here, here, and it stops at 2. And then it repeats again. So the period equals 2. This is not a periodic. This is not a periodic. This is not a periodic, okay? Anyway, 5, 7, 9. Let's look at 9. Okay, number 9. Let's identify the amplitude. Let's look at this. Let's see if we can figure this out. Remember, the amplitude is how tall it is. What is the amplitude of 9. Okay, look at it. I'm going to call on one of you. What is the amplitude of 9? What is the amplitude of 9? Let's go with Emily Rodriguez. What is it?
1.
Yeah, it's the midpoint. It's halfway, like the whole goes down 2. We can see the amplitude from the center up is 1. Perfect. Okay, so 9, 11. I think we're at I should write down. I always get confused as to what 9, 11, 13's next. Someone correct me if I'm wrong. So we're at 13. Okay, so now let's identify the amplitude and period of the function, then graph the function and describe the graph of g as a transformation of the graph of its parent function. Okay, so the parent function of this is y equals sine of x. So the only thing we have here is the a. And so that's our stretch factor. So let's go ahead and graph everything. So have your parent function there. I'm going to try to keep my notes here on the side so you can see what we're doing. But let's go ahead and graph it. Let's see. We have g of x equals 3 sine of x. Okay. Watch and learn, boys and girls. So here we go. Does it say how many periods to graph? I should look at that too. But here we go. I'm putting my coordinate plane, x, y. Now, look, it goes up to 3. So, hang on, let's see how many periods it says. A period of function. Then graph the function and describe. It doesn't say how many periods. I'm going to graph 2 periods. Okay. So, let's write down what we know. The amplitude is equal to 3. The period, remember the period is 2 pi over b. Now look, there's nothing in front of x, which means my x is 1. So it's 2 pi over 1. So my period is 2 pi. That means I'm going to finish the whole cycle at 2 pi. Okay, horizontal shift, no horizontal shift. Vertical shift, no vertical shift. So my amplitude of 3. So what I'm going to do is I'm going to go up at 3, and that's going to be my top of my function. My period is at 2 pi. So I want to make sure I end at 2 pi. So I'm going to do what I did before. I'm going to go the same numbers I did before. We're going to increase by pi over 2. That's pi over 2. 2 pi over 2 is pi. Then 3. Each one I'm adding pi over 2. Pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2, which is just 2 pi. And then you go in this direction. Negative pi over 2, negative 2 pi over 2, which is negative pi, negative 3 pi over 2, and then negative 4 pi over 2, which is negative 2 pi. Boom. Okay, there's my function. Let's graph it. It's the sine function. So where are my zeros at sine? Well, it's, look at your unit circle. I have a 0 at 0, 0 at pi, and 0 at 2 pi. Those are my 5 points, right? Those are my zeros. I'm going to stop because I feel like I'm going too fast. Are there any questions? Should I keep going? I'm assuming I'm good. So you graph the zeros. At sine, I got 0 here, 0 at pi, 0 at 2 pi. And then at sine, I normally go at 1, right? Pi over 2 is 1, but I multiply by 3 because I multiply by 3, so I go up here at 3. And 3 pi over 2, sine of 3 pi over 2, look at your unit circle, sine of 3 pi over 2 is negative 1. So instead of going negative 1, I go down to negative 3 because I multiply by 3. And I go here, and you go, whoop, boo. There's my period. I did 1 period. And then here, let's do my zeros. Again, on this direction, on sine, I have a 0 at 0, 0 at negative pi, 0 at negative 2. And then negative pi, right, I go up. So I got to go back down. And then I go back up. to 3. And then you just connect them. There you go. That's it. That looks a little pointy. Make it more round. But that's the amplitude of 3. That's all. That's it. I think that was 13, wasn't it? The hardest part is the H, when you get a shifty shift. That's 13. Let's do 17. Oh, 17. Are there any questions? I'm going to get rid of this in 10 seconds. Do you don't need it still? 5, 4, 3, 2, 1. Okay, let's look at 17. 17. Okay. G of x equals sine 2 pi over x. Okay. Let's draw our graph. This time we should do a cosine, huh? Okay, let's write down what we got here. There's only one number here that's a 2. What does that affect? What letter is that 2? Look at the 2. What does that affect? What is the 2? Is that the amplitude? Is that the period? Is it the horizontal shift or the vertical shift? Look at your notes. Let's go with Javier. What does that 2 affect? Is it the amplitude?
Period?
What's that?
The period?
Yes, very good. It's the period. So I'm going to write down everything that we have. The amplitude. The amplitude is 1 because the amplitude is, so it's normal. It stays the same as 1. The period. Remember, period is 2 pi over b. So you guys count. What is the period going to be? What is the period going to be? That means it finishes it at that, okay? What is the period of that going to be? Laura, what is it? What does it equal? Hello, Laura. Laura Punto. Are you there? Laura? I'm looking for you now. I'm not presenting. I'm looking for Laura. Make sure Laura's okay. Anyone know if Laura's okay? Laura! Oh, she's not even there. It's her sister's there. Did you say she's going to leave? Nope. All right, Laura, we'll check back on you. Should I mark her absent? I'll mark her absent. All right. Who should I call next? Lilia Medrano. What is my period?
2 pi over 2.
Oh, very good. Which would equal, Laura, Lilia, let's see. We have here 2 pi over 2, which the 2's cancel out, right? Which their period is going to be pi. Okay, this is important. So we're going to finish our cycle at pi. Horizontal shift, so period equals pi. Horizontal shift is 0. Vertical shift is 0. So the key thing is this. We finish our period in pi. Okay, so all we're going to do is let's go. Remember, we have 5 points. So let's look at the pattern here. Our period normally ends at 2 pi. And then look at we have a halfway point, because in the middle is half of 2 pi. It's pi. And then we go to 0. And in between here is half of that, right? So here's what we're going to do. We're going to, instead of going at, we're going to do the same thing. We're going to end it. We're going to do the same thing. Instead of going, we're going to end here. We did our 2 pi here. But instead of 2 pi, we're going to call this pi. Okay? So notice how I ended at the same spot. What is that? 1, 2, 3, 4, 6, 7, 8 over. So I went over and said that I went pi. And then we're going to cut it in half. And we're going to find the midpoint. Where's the midpoint? Should have a midpoint. Four, yeah. 1, 2, 3, 4. Here's the midpoint, right? Is that right? Did I draw this wrong? Oh, this is off. I want to do it. I messed up. I'm starting all over. I messed up. Bear with me. Do it real quick. We have g of x equals sine 2 pi x. And let's redraw. Sorry. So sorry. Bear with me here for a second. I don't know what I was doing. We want to go 8 over. We go 8 over. So, I mean, whatever. You just want to find a midpoint, but I'm going to go 8 over. 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. And we said our period is equal to pi. Okay, so this is going to be pi. Now we got to get the midpoint. So that's going to be 1, 2, 3, 4 is our midpoint. So we divide pi by 2. For our midpoint, we get pi over 2 to get that point. And then let's find the midpoint between this. So we do pi over 2. What's half of that? That would be, and we can figure it out, pi over 2 times 1/2 is pi over 4, right? So anyway, so the halfway point between this would be here, would be 2, and that would be pi over 4. Now, what's this point right here? Well, it's this plus this. We go pi over 4 plus this is 2 pi over 4. So then we have here is 3 pi over 4. Basically, you're adding these two and we get 3 pi over 4. That's how we're going to get our points. So to get our period, you get this point, you cut it in half, you get this point. You cut it in half, you get this point. Then you add these two, you get this point. Now I can do my 5 points. Now, our amplitude is 1. So we go 1, -1. And let's do our zeros. Remember, our zeros of pi are these 3, this one, the last one, and the middle one, right? Before, let's see, where's our other, let me get my other sign. So remember my zeros are 0, pi, and 2 pi, but basically it's the first one, the last one's a 0, then the middle one's a 0, and then I go above and below, right? So the first one's a 0, the last one's a 0, the middle one's a 0, then I go above and below, and there you go. Boom. And then you just repeat it over here. So pi over 4, so guess what this is? Negative pi over 4. And guess what this one is? Negative pi over 2. And then guess what this one is? Negative 3 pi over 4. And then we got negative pi. And we do the same thing. The first point's a 0. The last point's a 0. The middle point's a 0. And instead of going up, I got to go down because I'm going in the opposite direction. Below, above, and then you go, woo! And that's that's g of x equals sine pi x. And that's how you do it if you shift the period. You just have to figure out what the period is, and then make that your last point, cut it in half, get this point, then cut it in half and get that point. And then add these two and you get that point. And then you do the zeros with 0 first, last, middle, and then above and below. And boom, there's your point. And then you just repeat it over there. That's it. Oh my gosh. How long is this class? Is that what you're thinking, Lorenzo?
Yeah.
I know. How much longer? Still have a lot more to do. Sorry. 21. Which functions have an amplitude of 4? Well, this one does, and this one, and this one. It's just that this is negative, still amplitude of 4. So 21, what comes after 21? 21, 25 is next. Okay, now we have to do the horizontal shift. No, this is the vertical shift of +2, so that's pretty easy. Let's do the vertical shift of +2 on 25. So I'm writing it down. I am presenting, right? Okay, 25 is g of x equals sine of x minus 2. Okay, let's write down all we need to know. What's our amplitude? So we got an amplitude of 1, a period of 2 pi divided by, what's my b? 1, which is 2 pi. So my period is 2 pi. My vertical shift is -2. My horizontal shift is 0. So this is not that bad. This is actually pretty easy. So the vertical shift is this. This is all we're going to do. The horizontal shift is a butt kicker. That, in my opinion, the worst one is the horizontal shift. That's a butt kicker. Now, x. So our period is 2 pi. So let's do our 2 pi. Let's go 1, 2, 3, 4, 5, 6, 7, 8. And here we have 2 pi. Half of 2 pi, 1, 2, 3, 4, is pi. Half of pi, 1, 2, is pi over 2. Those are our key points. And then add these up, pi over 2, 2 pi over 2 is 3 pi over 2. Add your fractions on your own if you don't know how to do that. Our amplitude is 1, so we're going to go at 1, but here's the kicker. Our vertical shift is -2. So what that means, oh, I'm going to run out of room here, but it's okay, I got it. I got to get -2. Since my vertical shift is -2, that means my midline, if I did my other graphs, I had the midline right here. My midline is going to be at -2. So the vertical shift, what you want to do is you want to draw a line at -2. Just a dasher. Dink, 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 dink. Instead of putting my points on here, I'm going to put my points here. Okay, and that's all you got to do. So, let's see. Y equals -2x. So let's do my zeros for sine. I got to do a cosine. One of these got to be cosine. Got my 0. My first is 0. My last point is 0. So my 0, instead of being here, my zeros are going to be on the midline. And then my midpoint is also 0. And then remember, on sine, you go, where pi over 2 is, you go 1 above. And you go, let's see, we're going to go 1 below. So let's go down to -3. So this point, I'm going to go 1 below. And then you just draw it. Bum, 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 bum. And let's go in this direction. -pi over 2. -pi. I'm just mirroring this, right? -3 pi over 2, and then -2 pi. And then so we're going to do the same thing. Where are my zeros? I got a 0, I got a first, I got a last, I got the middle is my 0. Instead of going above, because it's negative, I go below. Here, and I'm going to go up 1 here, and it's going to look like this. It's like art class. Let's try to, so that's the vertical shift. I need to get a cosine in here. 25, 27, 29 is the next one. We'll check out 29. Are there any questions on that?
Sensei,
Yeah.
wasn't it positive 2
The
for 25?
this is supposed to be positive 2?
Yeah.
Well, if it is, let's see. Oh yeah, because this was in my way. Looked like a negative. Okay, so yes, it is positive 2. So how would that change it? So I did it wrong, but how would that change? That means that this line just goes up here at 2, and you do the same thing up there. Okay. Does that I'm sorry, who asked that?
It was
So I know
Alexis.
Alexis, does that make sense?
Yeah.
I mean, since I did it here at negative 2, you just do the same thing up here at positive 2. Draw your line. I mean, I could do it real quick. Should I do it, Alexis?
No,
Would
I
that
mean,
help?
it's okay. I get it. Like,
Okay.
I just wanted to.
Cool. Anyone else need me to do it? Because I want to move on if not. It's okay. I can do it real quick. I'm moving on. Okay, 29. Okay, so here, oh, here's a cosine. I'll do 29. Ooh. Yeah, I'm going to do this cosine at 29. So we can see a cosine. So cosine, so 29 is g of x equals 2 cosine x minus 1. Okay. Okay, let's go with Nicander. Tell me about these numbers, the 2 and the negative 1, as I'm drawing my graph. What do those affect on my graph?
2 is the amplitude,
Yeah.
and -1 is the vertical shift.
Yes, very good. So we got, and so let's write it down here. He's 100% correct. So the amplitude is going to be 2. That means we're going to stretch it at 2. So I'll just change my scale a bit. And then we have the period. I have a 1 here, so still 2 pi. 2 pi is my period. Now I have a horizontal shift is 0, but I got a vertical shift of -1. Okay, hopefully that's right. -1, right? I got a -1. Correct me if I'm wrong. Okay, so let me draw my scale. So I'm going to do it at 2 pi again. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 8 over. You can go 4 over if you want. 2 pi. Half of 2 pi is pi. 1, 2, 3, 4. So we go pi. And then half of pi is pi over 2. And then you add these, pi over 2, 2 pi over 2. And then add this over, we got 3 pi over 2. And then we have here, again, let's go, well, we'll go in that direction in just a second. So let's talk about what we got here. Vertical shift. So I'm going to do these. So what I'm going to do is I'm going to make these a scale of 1, 2, 3, 4, -1, -2, -3, -4. I have a vertical shift of -1. That means I'm going to take my ruler and I'll put my line, my midline here at -1. Okay. And amplitude of 2. So that means I'm going to go up 1, 2, and down 2 from here, right? An amplitude of 2. So let's talk about our key points for cosine, because we did a lot of sine functions. Let's talk about the key points of cosine. Now, cosine, my 0 and 2 pi are up on top, 1, and then my midpoint is at -1. and these are my two zeros. Okay? So my first and last are at 1. Should we do the zeros first? My two middle are my zeros. So these are my zeros, okay? Let's do the zeros first. So you have the midpoint, not the midpoint. Let's see. How do I describe this? No, let's do the first and last. First and last are at 1. So first and last are at 1. So instead of them being at 1, so here's my midline. My first and last are going to be at 2 above it because of my amplitude. So I go up 1, 2. Here's my first point. My last point, I'm also going to go up 1, 2. My middle point, which is here, I'm going to go down 2 from the midline because my amplitude is 2. And then everything else in between is a 0. 0, 0. So first and last are your top points. The middle point is your bottom point, and everything in between is your zeros. And so there's your cosine. Let's go here. Let's do it on this direction. Where's my purple pen? I got 1, 2. I got negative pi over 2. Let's mirror this. And then negative pi. And then negative 3 pi over 2. And then negative 2 pi. And so I got my first point is the top. My second point is at the top, 2 above. And my midpoint is 2 below, right? And then everything in between is my 0. 0 and 0. There's your cosine. G of x equals 2 cosine x minus 1. That's 29. How are we doing on time? We've been here for over an hour, but still, I still want to get some. They're just learning a lot today. Any questions on that? Oh. We good? What do we got next? That's 29, 31, 33. Oh, let's move on to see what else. 33, 35. Let's look at 37. 37, right? Okay. So now these have the shifts. In exercise 37-40, describe the transforming of the function of f represented by the function g. Now, I'm going to graph this so you could describe it. So this is the function f. What's going on? Well, we have an amplitude of 2. We have a horizontal shift of positive pi over 2. It's the opposite of this. So that means we shift it to the right, pi over 2, and then we go vertical shift of 1. So I'm going to do this one, and then I'll let you guys go. $37. It doesn't say to graph it, but I want to graph it so you guys know how to do this on your test. And you can see what the shifts are. Cosine. And it's cosine too, so it's good. Pi over 2 plus 1. The horizontal shifts, in my opinion, are the most challenging. They are the most challenging. Okay? These are the most challenging. So you got to practice these. I'm just going to do it. Amplitude is 2. Period is 2 pi over 1. There's nothing here multiplying, so we'll just say 2 pi. The horizontal shift is plus pi over 2. Because it's a negative, that means I go to the right this way, pi over 2. And the vertical shift is 1. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 2 pi, because that's my period. So now I'll end at 2 pi. Half of that, 1, 2, 3, 4, is pi. Half of that is pi over 2. Pi over 2, 2 pi over 2. So this has to be 3 pi over 2. Now, amplitude of 2. So I'm gonna do these increases of 1. Let's go 1, 2, 3, 4, 5, 6, 1, -2, 3, -4, 5, 6. And let's set this one up. So we have negative pi over 2, negative pi, -3 pi over 2, and -2 pi. Vertical shift of 1. So that means I'm going to draw my midline at 1, and then we'll put our points in. Should I pause? You guys need a second to catch up? So remember, cosine, the first is at 1, the last is at 1. But we're shifting at pi over 2. So we should continue this over. We should add on, we're shifting to pi over 2. So we should add a pi over 2 over here. So we have our last would be here. So I have pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, right? I'm just adding pi over 2 each time, right? This is 1 pi over 2. This is 2 pi over 2, which is pi. 3 pi over 2, 4 pi over 2. So what's this going to be? 5 pi over 2. That's going to be my last point. So I'm shifting to the right. So here we go. Remember, cosine. So we have a vertical stretch of 2. So my top, so I go up 1, 2. So my top point, what color should I do? Let's do the purple. So my top point, my first point is the high point. Go up 2. My last point, so instead of my first point being at 0, since I shifted to the right, my first point is going to be up here. My last point will be shifted pi over 2, will be here. So this is also up on the top. The midpoint, where's the midpoint going to be? 1, 2, 3, 4. Will be down to right here. And everything in between are my zeros. 0 and 0. So right, first point, last point, middle point, and then I got my zeros, and then just connect them. And then we repeat it in this direction, right? So first point. So now, well, and you can also like mirror it and say, okay, I go down to the midpoint. You can also just go mirror it, right? But where's my last? So I go over 1, 2, 1, 2, 3, 4. So my last point over here is going to be 1, 2, 3, 4. My last point will be over here. Or like you can repeat the pattern, right? You go up, then you go down, right? But my midpoint should be right here, right? 1. Midpoint should be 1, 2. Should be here. So I go down 2 right here. And my zeros are in between. 0, 0, and we go. Woo. And look at it. Does it look like a periodic function? Does it look like cosine? You can do the eyeball test and see if it looks right. That's hard. In my opinion, the horizontal shift is hard. Now, if there's a negative, these all rotate. So instead of it being, we'll do instead of the first and the last being on the top, the first and last will be on the bottom. This will be on the top, and the zeros will be the same. All right, if it's a negative. Anyway, that's 30. I feel like I did most of them. You can check your work on your answer key that I got for you. I don't want to hold you. Are there any questions? Hopefully school's. I'll be at school tomorrow if it's open. You guys know me. I'll be there. No questions? That was a long one. If there are no questions, I'll let you guys go. I'll see you tomorrow. I'll let you guys go. Sorry, that was a long one, but I love you guys. I love you all. I wish you're in the class. I wish you're in the class together. Bye, Stephen. Bye, Nikander. Bye. Boo. Stephen said bye. Bye, Stephen again. Bye, Danielle. Oh, everyone just left. Bye, Straya.